What's up? I'm Vin, and in this video, I'm going to go through this percents crash course, and I'll leave a link to a copy of this survival pack in the description below. Now, first up, section 1, we're going to go over what a percent means. And a percent is defined as out of 100. It tells you how many hundredths you have, and 100% represents the entire whole. And percents can be written three equivalent ways. We have percent form, fraction form, decimal form. And just know percents can be greater than 100%, meaning more than one whole. So now let's move on to the practice questions. And for question 1, we have write 8% as a fraction and a decimal. So for this one, we just have to remember that percent means out of 100. So when I read this, I'm saying 8 out of 100, which means 8 over 100. Okay, so this would be the fraction form of 8%. We just write the number in front all over 100. If we had to simplify this, so let's say we want to simplify this fraction. So if we want to simplify, then what we would do is we would divide the numerator and denominator by the greatest common factor. So let's say I divide top and bottom here by 4, and that would give us 8 divided by 4 is 2, over 100 divided by 4 is 25. So this would be the reduced fraction, but we weren't told to simplify here. And the 8 over 100 is actually a better form for us for when we have to write our percent as a decimal. Because 8 hundredths, we'll just write over here, it would be 0.08. Okay, so for this question here, if we're expressing 8% as a fraction unsimplified, we would leave it like this. And if we're expressing 8% as a decimal, we would write it in this form here. Question 2, we're going to write 80% as a fraction and a decimal. So for this one, we're going to take 80 and write it over 100. Remember, percent means out of 100, so we have 80 out of 100 like this. So this would be fraction form here. If we want to simplify this, so I'll just write over here, if we simplify the fraction, so I'll just say over here, we're going to simplify. We would take 80 over 100 and divide by the greatest common factor, which is 20 in this case. Okay, so we divide numerator and denominator by 20. 80 divided by 20 is 4. Over 100 divided by 20 is 5. So 4/5 would be the simplified form. But once again, we weren't told to write this in simplest form. So 80 over 100 is fine. And now for the decimal representation, 80 hundredths is the same thing as 0.80. Okay, so I could write my decimal like this, or I could even just say 0.8, but this is also equivalent. So this would be our solution to question 2. Question 3, at Bear Creek Middle School, there are 100 sixth graders. 39 of them have dogs at home. What percent of the sixth graders do not have dogs at home? So for this one, what we want to do is think about how many sixth graders have dogs and how many do not have dogs. So we're told here 39 have dogs at home. So what we could do is we could take 100 and we could subtract 39, and this will tell us how many of the sixth graders do not have dogs. Okay, so we're going to subtract here. So we can't do 0 minus 9. So what we could do is we could take this 10 and borrow and make this into a 9 and put a 1 here. Now we could do 10 minus 9 is 1. 9 minus 3 is 6. So this tells us 61 of the sixth graders do not have dogs. Okay, so this is how many 61 do not have dogs. But now when we think about this here, percent-wise, we have to say what percent of the sixth graders do not have dogs at home. Well, that's 61 out of the 100 total sixth graders. Okay, so there's 100 students in grade 6. 61 of them do not have dogs, but what percent is this? 61 over 100 is the same thing as 61%. Okay, so this would be the percent here. If the question instead asked what percent of the sixth graders have dogs, it would be 39%. Okay, so 39% because 39 out of 100 have dogs, but the question is asking what percent do not have dogs at home. So this is our solution. Question 4, at the start of the school year, a library had 100 books on the shelves. By the end of the year, the library had 135 books. What percentage of the original number of books does the library have now? So in this question, there's a lot going on, but we just have to break it down piece by piece. The actual question is asking us what percentage of the original number of books does the library have now? So if we look here between 100 and 135, the 100 books is at the start of the school year. So this represents the original amount. Okay, so I'll say the original number. so that it matches the question exactly. Okay, so this is the original number of books, and then this is the new amount. Okay, so the new amount. So now let's think about this. We're being asked to find the percentage of the original number of books. So the total at the bottom is going to be 100 because it's the percent of the original number. So this is going to be over 100. But now the new amount of books is 135. So we have to think about what percent this is. Well, remember, percent means out of 100. So we have 135 out of 100, which would give us 135%. Okay, so just know anytime you have a fraction with a 100 in the denominator, that numerator, you could just say that number and then percent next to it. Okay, so we would have 135%. So now before we move on, you might be looking at this number and thinking, wait, this percent is more than 100. But in the notes, we said that anytime you have a percent more than 100, you have more than one whole. So the fact that we started out with 100 books and we wound up with more than 100 books tells us that we have more than 100% because we have more than what we started with here. Later on in the packet, we'll talk about how to solve for the percent increase, but here we're finding the percent of the original. So since we have more than the original, we have more than 100%. In section 2, we're going to work with anchor percents and mental math. And for the notes here, some percents are easy to find with mental math, and these are called anchor percents. And here are some anchor percents that you should know. So when you have to find, let's say, 10% of a number, you could just divide that number by 10. And here are some other shortcuts that you could use. And here's just a few examples of how the anchor percents work. So if I have to find, let's say, 15%, I could find 10% of the number, 5% of the number, and then add those 2% together. And for something like 30%, I could find 10% of the number and then just multiply 10% by 3. So these are just some combinations here that we could use when working with anchor percents. So now for question 1, let's find 15% of 120 using anchor percents. So for this one, what I'm going to do first is I'm going to find 10%. Okay, so 10% of 120, this is equal to 120 divided by 10. And when you divide a number by 10, what I like to imagine when I'm dividing by 10 is I imagine the decimal in the number. So let's say 120 is 120.0. And I imagine the decimal and I move it one space to the left like this, which would give us 12. Okay, so when we divide here, we're just going to get 12 like this. So that would be 10% of 120. Now, I also have to find 5% of 120. And from the notes above, 5% is half of 10%. So I could take the 10%, 12, and take half of that. So I do 12 divided by 2 is 6. So this tells us then our answer, 15% of 120 equals, and I would do 12 plus 6. So you see I'm doing 10% plus 5%, which would give us 18, and this is our solution. Question 2, we're going to find 25% of 72. Now, when you want to find 25% of a number, you just take that number and you divide by 4. So we're going to divide 72 by 4. And the reasoning behind this, why we do this, is if you think about it, 25%, if we use the idea from section 1, is equal to 25 out of 100. And if I reduce this fraction, I divide the numerator and denominator by 25, I get 1/4. So I'm really just taking 1/4 of 72, which is the same thing as doing 72 divided by 4. So now I could say 4 goes into 7 one time. 1 times 4 is 4. I subtract, remainder 3. I bring down the 2. And now 32 divided by 4 is 8. 8 times 4 is 32. We get an exact match, so we get exactly 18. So we could say 25% of 72 is equal to 18. Question 3, we want to know which is greater, 40% of 50 or 20% of 90. And we have to justify our answer, which means we have to show work. So let's say I do 40% of 50 first. Okay, so for 40% of 50, what I'll do first, I'll use anchor percents. I'll find 10% of 50. And when you find 10% of a number, you just take that number and divide it by 10. So I do 50 divided by 10, which is equal to 5. So if I want to find 40% of 50, so for this, 40% of 50, I just take the 10%. So this is my thought process. For 40%, what I could do, I could say that this is equal to 4 times 10%. Okay, so I could do the 10%, but then just times 4. So I'm going to take here, the 10% of 50 was 5, and I just multiply it by 4 to get 20. So this tells us that 40% of 50 is equal to 20. But now let's find the other percent here. So 20% of 90. Now for this, you could just do 10% times 2, or if you think about it, 20%. So I'm just make this thought a little bit bigger. So we could also say that 20% is equal to 20 out of 100. And this is equal to 1/5 if I divide numerator and denominator by 20. So if I want to find 20% of 90, I could also just take 90 and divide it by 5. I could also, once again, find 10% of 90 and double it, but I could just do 90 divided by 5. So it depends on which one you want to do. But that's why it really helps to understand what percents are, because then it gives you options. Okay, so let's see. So 20% of 90 is equal to, so let's say I just divide by 5. So I do 90 divided by 5. And for this one, I could do the long division on the side here. So I have 90 divided by 5. 5 goes into 9 once. 1 times 5 is 5. Subtract. Remainder 4, bring down the 0. 40 divided by 5 is 8. 8 times 5 is 40. We subtract and get no remainder. So here, which percentage is greater? Now we just have to pick the bigger number here. See, this one is going to work out to a bigger number. 40% of 50 is greater. So I'll just say here that which is greater, 40% of 50 is the greater one. For these type of questions here, the math shown counts as the justification. So this would be a perfectly fine solution. Question 4, we're going to use anchor percents to find 43% of 60. So for this question, since we're using anchor percents, we want to think of 43% as 4 times 10%, and then we could say plus 3 times 1%. So let's say for this question, since we are using anchor percents, that we're going to use these two anchor percents, 10% and 1%. And we're going to build up to 43%. And our ultimate goal is to find 43% of 60. So this number here, the 60, is what we're targeting. So first, let's find 10% of 60. And when you're finding 10% of a number, you just take that number and divide it by 10. And I could say 60 divided by 10 is equal to 6. And then next, we need to find 1% of 60. So we could do 1% of 60 is equal to, we take 60 and this time divide by 100. Okay, in the notes, we said for the 1% anchor percent, we would divide by 100. And another way to see this would be if we're going from 10% to 1%, 10% divided by 10 equals 1%. So I'm just going to point that out. This divided by 10 is equal to 1%. So if I take 6 and divide by 10, that's going to give me 0.6, which is equivalent to 60 hundredths. 60 hundredths is 0.60, and when you have a decimal with a 0 at the very end, you could get rid of that 0 at the very end and have an equivalent decimal. Okay, so this is what we need now to answer the question. So the goal, once again, was to find 43% of 60. So now let's go ahead and build this up. So we have 4 times 10%. So we have 4 times 10% of 60 was 6. And now plus 3 times 1%, and 1% of 60 was 0.6. And now we work this out. 4 times 6 is 24 plus, and for this part, if we're multiplying decimals like this in our heads, I just like to think that I'm doing 6 times 3. 6 times 3 is 18. So if I multiply by 0.6, I just put an extra decimal here. That's going to give me 1.8. So now I just add this together. 24 plus 1.8 is going to give us 25.8. And this is our solution. Question 5, Hank is going out to breakfast with his friends at a diner. The total bill is $32.50, and he wants to give the waiter a 20% tip. How much will Hank and his friends pay in total? And we have to use anchor percents to answer this. So since we're using anchor percents, to find the 20% tip, what we're going to do is we're going to take 10% and multiply it by 2. So we're going to do 2 times 10%. And anytime I find a tip like this, if I want to give 20%, that's the math I'm doing in my head. is I'm just taking 10% and doubling it. So let's go ahead and do that. So first, we're going to take the total bill here. So we're going to take the $32.50. And for this, I'll just write 32.50, and we're going to find 10% of that. So we're going to find 10% of 32.50. And for this, when you want to find 10%, you're just going to divide the number here by 10. And now for the mental math, if you struggle with dividing decimals like this, what you could just think about is the decimal place. So for this one, if I'm doing 32.50 divided by 10, what I imagine is I just see the decimal point here and I move it to the left one space like this. Okay, if I was dividing by 100, then I would go 2 spaces to the left. But since we're dividing by 10, we just go 1 space to the left like this. So then that tells us here that 10% of 32.50 is just 3.25. Okay, I don't have to write that extra 0 at the end because it's at the very, very end of the decimal. So I could just say 3.25. So now when I want to find 20%, I'm just going to take this number here and double it. Okay, so next for 20%, so 20% of 32.50, now I could say is equal to 3.25 just times 2. And for this one, if you could do the mental math, great. Otherwise, you could just do the work on the side. If you do want to do this with mental math, what I like to do is I just double the whole number part. So I just think of 3 times 2 in my head. So I think, all right, 3 times 2 is equal to 6. And then I imagine I'm doing 25 times 2 is equal to 50. But since this has a decimal over here, like this, I would just put the decimal 2 spaces now to the left. So you see I go 1, 2, and over here I'll go 1, 2. So this here would work out to 6.50. So if I add these now, I would get 6.50. Otherwise, there's other ways we could do this. We could just do the multiplication here on the side. You don't have to do all of this math in your head. So if we want to practice multiplying the decimals out, we could say 3.25 times 2. And for this, 2 times 5 is 10. I put a 0, carry the 1. 2 times 2 is 4, plus 1 is 5. And then I have 2 times 3 is 6. And since there are 2 decimal spaces over here that we ignored, we have to pay back 2 decimal places like this. So that's where, once again, 6.50 is coming from. However, the question is asking, how much will Hank and his friends pay in total? So now what we have to do is we have to add the total bill and the tip. So here we take the total bill now. So we have over here, I'm going to say $32.50. And we're going to add, let's see, how much money are we adding? We're adding $6.50. Okay, so we work this out. 0 plus 0 is 0. 5 plus 5 is 10. So I put a 0, carry the 1, bring down the decimal. 1 plus 2 is 3. 3 plus 6 is 9. And then we just bring down that 3. So this tells us here the total amount that Hank and his friends will pay. We're going to say $39 is the total amount. And now in section 3, we're going to be converting percents, fractions, and decimals. And the notes for this section here tell you how to convert from percent to decimal, decimal to percent, percent to fraction, and from fraction to percent. For the first set of practice questions in part A, we're going to go from percent to decimal form. And that's for questions 1 through 5. Once again, we are converting the percents to decimal form. And for question 1, we have 5%. So if we forget what was just written in the notes, and in the notes we said to go from percent to decimal, we just divide the number by 100. But if we forget this, we just have to think about what the definition of percent is. And percent means out of 100. So 5% we could say is 5 out of 100. So this is where the divide by 100 is coming from in the notes. It just comes from the definition of percent. And now 5/100ths in decimal form is 0.05. So this would be our solution to question 1. 40% means 40 out of 100. So we could say 40 over 100. And this is the dividing by 100 step from the notes. And now I just have to write 40/100ths, which is 0.40. So this would be the decimal form of 40%. And I could leave it as 0.40, or I could say over here, I'm also going to write, we could say 0.4. These two decimals would be equivalent because we have a 0 at the end, which is not going to add any extra value to 0.4 on its own. Question 3, we're going to convert 12.5% to decimal form. So we could start by writing 12.5 over 100. From the notes, I said that when we want to go from percent to decimal form, we just divide the decimal by 100. So from here, let's think about what happens when you divide by 100. So when you have a decimal like this and you divide it by 100, what's really happening is the decimal just moves 2 spaces to the left. So what I imagine with questions like this is I just take the decimal and I go 1, 2. Okay, so I move the decimal 2 spaces to the left, and this tells us our answer is going to be 0.125. Okay, when I write my decimals like this without a 0, that's fine, but I like to write the 0 to the left here just so it's very clear what our number is. Now, one thing I want to point out here as a side note is that there's another way to see this question. So what you could also do is you could take 12.5 over 100, and we could multiply by 10 in the numerator and the denominator. And what this will do is in the numerator, for one, it's going to move the decimal to the right 1 space, giving us 125. Over 100 times 10 is 1,000. And then we could see 125 thousandths is the same thing as 0.125. And we get the same exact answer. Question 4, we're going to convert 150% into decimal form. So for this one, we could start off by saying 150% is the same thing as 150 out of 100. And from here, if you just recognize that this is equal to 1.5, then excellent. Okay, so this would get us to our answer right away. But if that's not making sense, then another way to think of this is you could think of 150 out of 100 as the fraction 3/2. And the way we could get there is we divide the numerator and denominator by 50. And from here, we get 3 over 2. And then if you remember how to convert fractions into decimals, then you could go right from here to the answer. So this, you could say, is the same thing as doing 3 divided by 2. And I could say 2 goes into 3 one time, and then 1 times 2 is 2. I subtract. I have remainder 1. And then I could do something like this. I could put a 0.0 here, and then put a decimal up here, and then bring down this extra 0, and say 10 divided by 2 is 5. 5 times 2 is 10. And I get no remainder, so this divides, and I could stop here at 1.5. So that's another way to see this. A third way to see this when we go past 100% is we could also say that 150% is the same thing as 100% plus 50%. And then 100% is the same thing as 100 out of 100 plus 50% is the same thing as 50 out of 100. And now this, I could say 100 divided by 100 is 1. Plus 50 out of 100, or 50 hundredths, is the same thing as 0.50, which also gives us, I'll just write over here, 1.50, which is equivalent to 1.5. Question 5, we're going to convert 0.8% into decimal form. So we could start off here by saying 0.8 out of 100. Okay, so we have 0.8 divided by 100. And my thought process for a question like this is to just take 0.8 and move the decimal 2 spaces to the left. Now, notice that I only have this 0 over here. So I could throw an extra few zeros like this. Even though I would never write my numbers like this, you can think it or just use this as a way of showing your work. So now what we're going to do is we're going to move the decimal 2 spaces to the left like this. And notice what that's going to give us. That's going to give us the decimal now at this location over here, telling us that 0.8 over 100 is the same thing as 0.008. Okay, so that's what we would get as our solution. Now, another way to see this, so I just want to point out something else we could have done here, is take 0.8 over 100, and we could multiply the numerator and denominator by 10. And if I do 10 times 0.8, the decimal moves 1 space to the right to give us 8 over, we'll just make that a little neater. So we have 8 over, 100 times 10 is 1,000, and then 8 thousandths is the same thing as 0.008. And notice I get the same exact answer. For part B, we're going to convert from decimal to percent. And we're going to be doing this for questions 6 through 10. We're going to convert the decimals to percents. So for question 6, we have 0.04, and we want to convert this decimal to a percent. So if we just follow the notes tell us to just multiply the number by 100 and then throw the percent in front. So we could say here that 0.04 is equal to, and I take 0.04 and I multiply it by 100, and that allows me to put the percent sign in like this. So this is equal to, I just move the decimal 2 spaces to the right. Okay, when you multiply by 100, that sends the decimal 2 spaces to the right. So my thought process for a question like this, when I have 0.04, I'm just imagining that decimal going 2 spaces to the right, and that would give us just 4.0. Okay, so I'll even just move this 0 over here on this side and get rid of the other one, but that's where the 4 is coming from. That's how I see the decimal moving, giving us 4%. Now, another way to see this, okay, so let's just first circle our answer. We have 4%. But another way of seeing this is that 0.04 is the same thing as 4/100ths. And 4 out of 100 is the same thing as 4%, giving us the same exact answer. Question 7, we want to convert 0.145 into a percent. So for this one, we could just take 0.145 and we could multiply it by 100. And then that's going to allow us to express this decimal here as a percent. So let's go ahead and multiply by 100. And when you multiply by 100, the decimal is going to go 2 spaces to the right. So it's going to go from this location here to between the 4 and the 5, telling us that this decimal as a percent is going to be 14.5%. Okay, so the shortcut here is just move the decimal. So we have the decimal here. Just move it 2 spaces to the right and then throw the percent in front. Question 8, we're going to convert 1.75 into a percent. And for this one thing that I think about before I jump into the question is I look at 1.75 and I notice that this number is greater than 1. So that tells us that 1.75 is more than, so this is going to be more than 100%. Okay, let me just make this neat. So more than 100%. And that goes back to section 1, that anytime you have one whole equals 100%. So when you go more than 1, your percent goes more than 100. Okay, so that's my little mental check before I jump into the question. But if I just follow the notes here, then all I have to do is just take 1.75 and multiply it by 100, and then that'll tell me what percent I'm dealing with. And I just imagine here this decimal goes 2 spaces to the right in this location here. So this would give us, we could say our final answer is 175%. Question 9, we have 0.007, and we want to write this decimal as a percent. Now, there's a few different ways we could handle questions like this. So for this one, of course, I could just take 0.007 and just move that decimal 2 spaces to the right, and then that would tell us that our final answer here is going to be 0.7%. Okay, so this would be our answer to question 9. But another nice way of seeing this, let me just move this stuff over here. So I want to look at a second approach. So for a different approach, I could take 0.007 and express this as 7 thousandths. So I have 7 over 1,000, but anytime I want to write a percent would have a denominator of 100. Okay, like when I'm going from fraction to percent, I really want to have a denominator of 100. So what I could do with this is I could divide the numerator and denominator by 10. Okay, so this way is a little bit trickier, a little bit more advanced, but I just want you to really get the concept of what percents are. So here, if I do 1,000 divided by 10, that's 100. And if I do 7 divided by 10, 7 divided by 10, just think about that over here. 7 divided by 10 is the same thing as 7/10, which is 0.7. So I would get a numerator of 0.7. And if I have some number over 100, I could write that number in front of a percent sign. So that's another way of seeing why we get 0.7%, or we could just follow the notes. Question 10, we're going to convert 2.4 into a percent. So for this one, we want to do 2.4 times 100, and then we could throw in the percent like this. But just know when you multiply 2.4 by 100, that's the same thing as doing 2.40 times 100. Okay, so with a number like this, 2.4, I could put an extra 0 at the end and it won't change the value of the number. It's just going to change its representation, what it looks like. And now when you multiply something by 100, the decimal in your original number just moves 2 spaces to the right. So you could imagine here if the decimal goes 2 spaces to the right, we're just going to get 240. So when we do 2.4 times 100, that's 240, and then we just throw in our percent, telling us 2.4 equals 240%. For part C, we're going to convert from percent to fraction form. And this is going to happen for questions 11 through 15. Once again, we are converting the percents to fractions, and we are going to simplify fully. So let's start here with question 11. We have 20%. And for these type of questions, just remember percent means out of 100. So I'm going to say 20 out of 100. And then I just have to divide by the greatest common factor. And the greatest common factor between 20 and 100 is 20. So I could divide the numerator and the denominator by 20. And now I just simplify here. 20 divided by 20 is 1 over 100 divided by 20 is 5. So we get 1/5. Question 12, we have 75%. And 75% means 75 out of 100. And for this one, I would divide the numerator and denominator by 25. That is the greatest common factor of 75 and 100. And then we do 75 divided by 25 is 3 over 100 divided by 25 is 4, giving us 3/4. Question 13, we have 6.25%. And for this, we're going to start by writing 6.25 over 100. And now for this one, it could be a little bit tricky to simplify because we have this decimal. And technically, we could stop here since we were dealing with kind of a strange percent. But let's go ahead and make this look as nice as possible. So for this one, let's say I multiply the numerator and denominator by 100. The reason I would do this is to turn 6.25 into a whole number. So when I multiply 6.25 by 100, the decimal moves 2 spaces to the right, giving us 625. And now we're over 100 times 100. Well, for this, without a calculator, I just say 1 times 1 is 1. And then there's 1, 2, 3, 4 zeros. So 1, 2, 3, 4. And now if I want to reduce this, let's say first I divide by 25. Okay, so I divide by 25 in the numerator and denominator. Now, 25 times 25 is 625. So if I do 625 divided by 25, that's just going to give us 25 on top. Over, and then for this one, I could go ahead and do long division, or I could just think of it like this. Okay, so a nice little mental trick to doing questions like this is I know that when I do 100 divided by 25, that I get 4. If I did 1,000 divided by 25, well, I would have 4 groups of 25 every time I have 100. So then I would just have to multiply this by 10, telling me 40. Okay, so see here, if I just take an extra 0 on top, then I'm just going to put an extra 0 here in that quotient. And then if I were to do 10,000, so 10,000 divided by 25, I would just throw in an extra 0, giving us 400. Okay, so this now gives us 10,000 divided by 25 is 400. Okay, so this is just a nice way to do mental math. And now I notice these two numbers are divisible by 25. So I divide by 25 one more time. And now in the numerator, I have 25 divided by 25 is 1 over 100 divided by 25. Well, let's think about this. If a moment ago I just said, so I'll just write it over here, that 100 divided by 25 was equal to 4. Well, if I do 400 divided by 25, I could just take this here and do times 4 on both sides, telling us that 400 divided by 25 is equal to 4 times 4, which is 16. Okay, so this would give us 1/16 as our fraction. So 6.25% we could say is 1/16. Question 14, we have 0.4%. And if we want to turn this into a fraction, first we could just take 0.4 and write it over 100 because percent means out of 100. So if we want to get rid of the percent sign, we just divide by 100. And now from here, what I'm going to do is I'm going to take this and multiply this fraction by 10 over 10. And the reason I'm doing that is I want to get rid of the decimal on top. So the decimal, now when we multiply it by 10, will go 1 space to the right, giving us 4 over 100 times 10 is 1,000. And now from here, we could just divide the numerator and denominator by 4. And this is going to get us to our final answer. So 4 divided by 4 is 1. And now for this, I have 1,000 divided by 4 is 250. Okay, so this would be our simplified fraction for 0.4%. Question 15, we have 120%. So first we could say 120 over 100. And we could just start simplifying here. So looking at these two numbers, I see they're both divisible by 20, and that is the greatest common factor. So we could just go divide by 20, top and bottom. 120 divided by 20, that just simplifies to 6 over 100 divided by 20 is going to give us 5. So we get 6/5 like this. So our solution to 15 is going to be this fraction here, 6 over 5. For the next set of questions, 16 to 23, we're going to convert the fractions to percents. So question 16, we have 3/5, so 3 over 5. Now the first technique I want to look at here is making the denominator into a denominator of 100. So if I want to turn 5 into 100 by multiplication, I just have to think about 5 times which number is equal to 100. And the way of getting that is we could also just say in our heads, what is 100 divided by 5? And that's equal to 20. So I'm going to multiply the numerator and denominator of our fraction by 20. And then I get 3 times 20 is 60 over 5 times 20 is 100. So we get 60 hundredths. And when you have your fraction over 100, you could just write the numerator in front of a percent. So we could say that 3/5 is equal to 60%. Question 17, we're going to convert 11 over 50 into a percent. So we have this fraction over here, and since we have a denominator of 50, we could just multiply numerator and denominator by 2, and this will turn our original fraction into an equivalent fraction with a denominator of 100. Okay, so this is the nicest way, in my opinion, to turn a fraction into a percent, is to just change that denominator into a denominator of 100. But make sure that whatever you multiply the denominator by, that you do the same thing to the numerator. So we do 11 times 2 is 22, and then 22 out of 100 is the same thing as 22%, and that's our solution to 17. Question 18, we have 3/10, and for this fraction here, we could multiply by 10 over 10, and this gives us the equivalent fraction 30 over 100. And when you have a denominator of 100, you could just write the numerator in front of a percent. So this tells us that 3/10 is equal to 30%. Question 19, we have the fraction 9 over 25, and we want to write this as a percent. So we have 9 over 25, and if our goal is to have a denominator of 100, well, in this case, we would multiply 25 times 4. But if we multiply the denominator of our fraction by 4, we have to multiply the numerator by 4 as well. So we get 9 times 4 on top is equal to 36. And when you have 36 over 100, that is equal to 36%. And that's our solution to question 19. Question 20, we have 4/15, and we want to convert this into a percent. So for this fraction here, this is not going to be as easy as just multiplying 15 by some number to make 100. It's a little bit trickier to come up with the number in this case because that number is going to be a decimal. So what we could do here is we could take 4 and divide by 15 and do long division. But now we're going to be dealing with decimals because when we go to do 4 divided by 15, the closest we could get is 0 times 15. So in situations like this, we take the 4 and we put a decimal, and then we could put as many extra zeros as we need. So here, let's say I just put 2 zeros for now, and I just start the process. So what I'm going to do is I'm going to put the decimal right above. I'll just make this a little neater. I'm just going to line it up with the decimal over here. So now I could look next to 40 divided by 15, and we could get as close as 15 times 2. Okay, so when I do 2 times 15, I get 30, and then I subtract, which gives us a remainder of 10, and I bring down the next 0. And from this part on, I could just keep adding extra zeros as I need them. So now I have to do 100 divided by 15, and the closest we could get is times 6. Now, as a side note, 15 times 6, if I work this out, I have 6 times 5 is 30, so a 0, carry the 3, and then 6 times 1 is 6, plus 3 is 9, giving us 90. So when I do 6 times 15, I get 90, giving us 10 extra. Okay, so we have a remainder of 10, which notice that we had a remainder of 10 before, and we just keep bringing down zeros. So this process now is going to continue forever. When I do 100 divided by 15, I could get as close as times 6, which would give us 6 times 15 is 90. I get remainder 10, and I would just keep bringing these down repeatedly. So I could do that forever, or I could just say here that these 6s are just going to keep repeating. So 4/15, what this tells us, is equal to 0.26 repeating. But now, when we want to convert a decimal into a percent, decimal to percent, we just multiply the decimal by 100. So for the next line here, what I'm imagining is that we have 0.26 repeating. So let's say I write a few of them like this, and this goes on and on forever. And I multiply this by 100, and then I could throw my percent on at the end. But what I'm looking for here is the decimal is going to go 2 spaces to the right like this when we multiply by 100. So this would tell us then that our percent is going to be 26.6, and I would just keep writing 6s like this, or I could put the bar above like this, and this means repeating. And then I could throw in my percent like this. So we have 26 point repeating 6% would be the percent form of 4/15. Question 21, we have 5/16. And for this, we could start by taking 5 and dividing it by 16. So this is the same issue as the last question here. 5 is not divisible by 16. The closest we could get is 0 times 16 is 0. So then I have to put a decimal here, and I could put one right above as well and start adding some extra zeros. But now I could do 50 divided by 16. I could get as close as times 3. 3 times 16 is 48. And I subtract. I have a remainder of 2. So then I could just put an extra 0 and bring it down. Okay, so the reason I could do this is I put 5.0. So all the zeros after this are not adding any value to the original number 5. So that's why this works. Now I could do 20 divided by 16. I get as close as 1 times 16 is 16. Subtract, remainder 4, put an extra 0, and bring it down. So here, now I could do 40 divided by 16. I could get as close as times 2. 2 times 16 is 32. I subtract, and I have a remainder of 8. And now 1 extra 0. So for this, 80 divided by 16, we could get exactly there by doing 5. Okay, so we have 5 times 16 is 80. We subtract, and we have no remainder. Okay, so this tells us what we accomplished here. This tells us that 5/16 is equal to 0.3125. So if we want to write this fraction as a percent, first we turn it into a decimal, and now we can just take this decimal here and multiply this decimal by 100 and put the percent in front of all of this. Okay, so now we just look at the decimal. The decimal, when we multiply by 100, is going to go 2 spaces to the right. So we could say 31.25% is our solution to question 21. Question 22, we're going to convert 7/12 into a percent. So we could start by doing 7 divided by 12. And for this one, we can't get 12 to go into 7, so we start with a 0 at the top. But if we put a 0 at the top to start, then we put a decimal and a 0 inside, and we're going to put a decimal right above and now start the process. So here, 70 divided by 12, we could get as close as times 5. Okay, so 5 times 12 is 60. So we subtract 60, remainder 10, put an extra 0, and then bring it down. And for this one, we could get as close as 12 times 8. Okay, 12 times 8 is 96. We subtract, and we have a remainder of 4. Put another 0, then bring it down. 40 divided by 12, we could get as close as times 3. And now 3 times 12 is 36. Subtract, remainder 4. So I think the trend now has been set. We bring down the next one here, and we could get as close as, once again, times 3 again. But when we subtract, see how we're just going to get a 4. So this pattern is going to repeat. So we're going to get 0.58 and then repeating 3 after. Okay, so how this helps us, we could say that 7/12 is equal to 0.583, and then the 3 repeats. Okay, so for this one, I'm just going to go ahead and put the bar above. So now when we want to write out our percent, we're going to take the decimal here, 0.58, repeating 3, and multiply by 100. And then we could put the percent like this. Okay, and the decimal is going to go 2 spaces to the right when we multiply by 100. So this will give us 58 point repeating 3%. And that is how we express 7/12 as a percent. Question 23, we're going to express 2/9 as a percent. So we could start by saying 2/9 is equal to 0.2 repeating. Okay, so 2/9 would just be a string of 2s after the decimal. Now, this is just a fun property of having a denominator of 9, or even having a denominator of 99 or more than that. Okay, so just a side note here. So this is just something that's cool about having a denominator of 9, is this is where the repeating patterns exist. So if I had something like, let's say 5/9, 5/9 would be 0.5 repeating. Okay, so this would just go on and on like this. If I had something like, let's say 2/99, then 2 would repeat every 2 digits. And this would give me 0.020202, and this pattern would continue like this. If I had 123/999, this would be 0.123123, and so on like this. All right, so that's how I'm able to do this without doing the long division. This is just a fun fraction to be able to work with, and a nice little part of math to know. This like little 9 pattern here. So with this, we have the fraction 2/9 is 0.2 repeating as a decimal. So I would just take 0.2 repeating as a decimal and multiply it by 100. And then I could put my percent in to see what would be my percent. So when we multiply any decimal by 100, the decimal just goes 2 spaces to the right. So this would give us 22.repeating2% like this. Okay, so since we have just a string of 2s forever, after the decimal, the 2s will just keep going, and this is our percent. For the last 2 questions, we're going to do word problems. And for question 24, we have in a class of 24 students, 21 are present. What percent of the class is present? So first, what we could do with this information is we could make a fraction. So the number of students that are present is 21. And we were told that in this class, there are 24 students total. So we put the part here over the whole, okay, when we're making our fraction. So the part of the class that is there is 21, and the whole class is 24. And now what we're going to do is we're going to convert this fraction into a percent. But when I do questions like this, if I have something like 21/24, first I would want to reduce this. So I'm going to divide the numerator and denominator by 3. And that's going to simplify our fraction. So we have 21 divided by 3 is 7, over 24 divided by 3 is equal to 8. And now from this step, what we could do is we can convert 7/8 into a percent. So I'm going to start over here by writing 7 divided by 8. So we do the division. Now 8 goes into 7 0 times. So now I could put a 0.0 and put my decimal above. And now I'll do 70 divided by 8. I could get as close as 8 times 8 is 64. If I went one more, like let's say I try 8 times 9, I would get 72, which goes past 70. So that would be no good. And now 70 minus 64 is 6. I put an extra 0 and carry it down. And now 60 divided by 8, I could get as close as times 7. 7 times 8 is 56. We subtract remainder 4. 1 extra 0 comes down. And now 40 divided by 8 is 5. And 5 times 8 is 40. So this divides nicely, no remainder. So what we could say with this, now I'll just write this over here, is that 7/8 is equal to 0.875. But we have to express this decimal now as a percent. So we just went from fraction to decimal form, and now we could finally go to percent form. So we take 0.875 and we multiply it by 100. And then we could put our percent in, and when we multiply by 100, the decimal is going to go 2 spaces to the right, giving us 87.5%. Okay. Now at this stage here, you might just be able to go to percent very quickly, because if you think about it, if 21 out of 24 students are there, that's most of the class. So a does my answer make sense little mental check is you would think about which percents, like which percent makes the most sense here. So this one, or this one. Well, if most of the class is there, that's almost 100% attendance, then this answer here is the most reasonable. 8.75% is too little, especially once again, 24 students total. There's 21 out of 24 kids in the class that are there at that moment, okay, or that day that this is being looked at. And this is less than 1%, so that's like super small. So this is the only one that's reasonable, 87.5%. Question 25, a jar contains 40 marbles, 8 are blue. What percent of the marbles are blue? So for this one, there are 8 blue marbles out of the jar contains 40 marbles in total. So for this, what we could do is we could start by reducing this fraction. We could divide the numerator and denominator by 8, and this gives us 8 divided by 8 is 1, over 40 divided by 8 is 5. And then we get 1/5. So from here, we could do the division, or we can remember that when we want to go from fraction to percent, the easier way to do it is to take your fraction and make an equivalent fraction that has a denominator of 100. So I can multiply 1/5 by 20 over 20, and that gives us 1 times 20 is 20, over 5 times 20 is 100, and 20 hundredths is equal to 20%. Okay, remember, percent means out of 100. So since we have 20 out of 100, we're going to get 20% for question 25. In section 4, we're going to be finding a percent of a number. And the notes for this section say that to find a percent of a number, we convert the percent to a decimal, then multiply. So the percent of a number equals percent as a decimal times the number. So now let's apply this to the practice questions. So for question 1, we have an animal shelter has 180 animals. 30% of the animals are cats. How many cats are in the shelter? So what we do here, once again, is we convert the percent to a decimal. So we have 30%, which we could express this as 30 out of 100. And then 30 out of 100 is 30 hundredths, which is 0.30. Okay, so that's our percent as a decimal. And we multiply that by the number. So we're just going to take that decimal here and multiply it by the total number of animals, which is 180. Okay, so we're doing 180 times 0.30. And when I do something like this, multiplying a whole number in a decimal, I like to pretend that I'm just doing 180 times 30. Okay, so I just multiply this, and then I'll just worry about the decimal places at the end. So I have 0 times 0 is 0. I'm multiplying by 0 3 times. So in my first row, I just get a bunch of zeros. And now I put a placeholder, and I do 3 times 0 is 0. 3 times 8 is 24. So we have a 4, carry the 2. And then 3 times 1 is 3, plus 2 is 5. And if we add all this up, we get 0, 0, 4, 5. Okay, I'll just make that a little bit neater. So we get a 4 here and a 5 here. But over here, what would be the difference? Well, when we have this number over here, notice that there's 2 decimal places. Okay, so 2 decimal places. So that means that I'm going to take my decimal point over here and move it 2 spaces to the left. Okay, so we would get 54, and choice C would be our answer. Now, before we move on, I just want to point out that there is more than one way that we could do this. So we can express the percent in fraction form and multiply with the percent in fraction form. So I could take 180 and multiply this by 30 over 100. And when you have 100 in the denominator and you have numbers with zeros at the end, you are allowed to cross off common zeros. Okay, so just a little mental math here, or a little quick math so you don't have to do multiplication then division. I could cross off this common zero here, and then notice I have a common zero here that I could chop like this. And now all I am left with is 18 times 3. And if I do 18 times 3, I'll just write that over here. 18 times 3, notice this gives us 3 times 8 is, we have 24. So we have a 4, carry the 2. And then 3 times 1 is 3, plus 2 is 5. And we also get 54. Okay, so this is another way to get to our answer. Question 2, a zoo has 250 reptiles. 28% of them are snakes. How many snakes are in the zoo? So for this one, let's take the percent here. So 28%, we could express 28% as 28 out of 100. And then as a decimal, this would be 0.28. So what we could do here is we could multiply 250 by 0.28. So let's go ahead and do that. So we have 250, and we're going to multiply this by 0.28. Now, for this one, what I could do is I could just pretend at first that I'm doing 250 times 28. Okay, so that's like my thought process here, that I'm just pretending this doesn't say 0 point. I'm just going to multiply it as if I'm just doing 250 times 28. So I do 8 times 0 is 0. 8 times 5 is 40, so I have a 0, carry the 4. And then we have 8 times 2 is 16, plus 4 is 20. So we have this first row completed. We put a placeholder, and now we continue. 2 times 0 is 0. 2 times 5 is 10, so we carry the 1. I'll just get rid of this one. So we have 2 times 5 once again is 10, so I put a 0. Carry the 1. 2 times 2 is 4, plus 1 is 5. And that brings us here. We add this up, so we get a bunch of zeros until we do 2 plus 5 is 7. But notice there are 2 decimal places here that we ignored. Notice that we have 2 digits after the decimal. So that means we would have to move this decimal point here. Imagine we have a decimal here. We would just move this 2 spaces to the left, giving us 70. Okay, so how many snakes are in the zoo? There are 70 snakes. And this is, once again, just multiplying 250 by 0.28. Now, before we move on, I just want to show how to do this question using anchor percents. And the idea being that in math, it's good if you could do a question more than one way. That really helps you understand the bigger ideas. Okay, so let's see how we could do this with anchor percents. So for this, if I want to build 28%, I'm going to do that by taking 30%. So I have 30% minus 2%. So first, let me start with 10%. Okay, so I'm going to take 10% of 250. And remember, from anchor percents, when you want to take 10% of something, you just divide that number by 10. And in this case, we would get 25. You could just imagine if we had a decimal over here, it would move 1 space to the left, giving us 25. And now I also want to look at 1%. So 1% of 250 is equal to, the decimal moves now 2 spaces to the left to give us 2.5. So now let's see, how can we build 30% minus 2%? So let's see what we could do with this. So we could take the 10% of 250 and multiply by 3. So I could take 25 times 3, and this would give us the 30% of 250. And now minus 2%, I would take the 1% of 250 and multiply that by 2. So I'd have 2 times 2.5. And now this gives us, let's see, 75 minus 2 times 2.5 would give us 5, giving us exactly 70, which matches the number of snakes that we found using this decimal multiplication. Question 3, a video game has 500 players online. 64% of the players are playing multiplayer mode. How many players are in multiplayer mode? So for this one, let's start out here by taking the percent, and we're going to turn 64% into a fraction. So we have 64 out of 100. Now we could express this as 0.64, but I want to point out how we could be flexible with questions like this. So since we're going to be taking 64% of 500, I would prefer to use the fraction form here to help us. So I'm going to take 500 and I'm going to multiply it by 64 out of 100. And the reason I do this is anytime you have common zeros in the numerator and denominator and everything is attached by multiplication and division, you could cross off the common zeros. So I cross off these 2 zeros with these 2 zeros. And now all I have to do now is multiply 5 times 64. So I'll just do that on the side. We get 64 times 5. And we do 5 times 4 is 20. So 0, carry the 2. And then 5 times 6 is 30. 30 plus 2 is 32. And we get 320, choice C. Question 4, a pet store receives 160 fish. 12.5% of the fish are goldfish. How many goldfish did the store receive? So here we're going to take 12.5% of 160 because we were told the pet store receives 160 fish total and 12.5% of them are goldfish. So let's see, 12.5% we could say is equal to 12.5 out of 100. And when we divide by 100 with a decimal in the numerator, we just move the decimal 2 spaces to the left. So this would give us 0.125. So we're going to multiply 160 by 0.125. So let's do that. We have 160 times, and then we have 0.125. Now, when I do this, my thought process before I get started, I just pretend that I am multiplying 160 with 125. And then I worry about the decimals at the end. So I see here that there are 3 digits after the decimal. So then I'm just going to move the decimal 3 spaces to the left when we're done. And I'm just going to move this up here so we have some space. So now let's get started. We have 5 times 0 is 0. 5 times 6 is 30. So we have a 0, carry the 3. And then we have 5 times 1 is 5 plus 3 is 8. Now we put our placeholder and we move to the next value here. And I'll just cross this off so we don't confuse it for the next part. So we have 2 times 0 is 0. 2 times 6 is 12. So we put a 2, carry the 1. And then 2 times 1 is 2, plus 1 is 3. And then when we go to a third row, we have to put 2 zeros as a placeholder. And now we're doing 1 times 0 is 0. 1 times 6 is 6. And 1 times 1 is 1. And then we have 0 plus 0 plus 0. Both times will give us 0. 8 plus 2 is 10, so we have a 0, carry the 1. 1 plus 3 is 4, plus 6 is 10, so 0, carry the 1. And now we put our 2. And remember, there were 3 digits here. Okay, so 3 digits after the decimal. So when we worry about where do we place our decimal when we're done, we're going to move this decimal here at the end 3 spaces to the left. So we're going to get 20. Okay, so this is where we're going here. But remember, at the end in math, no matter which type of question you're doing, you should ask yourself, does my answer make sense? So if I'm looking at, let's say, 12.5%, so a little estimation strategy. Well, I could just think of 10% of 160 from anchor percents. I just divide 160 by 10 and I get 16. So I know our answer has to be a little bit more than 16. So that's why 20 is the only one that is reasonable. The problem with something like 40 is if I did 20%, do you see how 20% of 160 would be 16 times 2? I would just double 10% of 160. And that would give me 32, which is way too much out there. See how 32 is past 20, and our answer 40 here is more than 32. So this 40 is more than 20% of 160. So this one's no good, and this is definitely no good. Okay, so that's why, once again, these are out. And then choice A is no good because 10% of 160 is 16, and 10 is less than that. So 10 is less than 12.5% of 160. Okay, so this one doesn't work. Definitely choice B. Question 5, a dog training class has 120 dogs. 35% of the dogs are puppies. How many puppies are in the class? So for this one, we're just going to take 35%, and we start by expressing this as 35 out of 100. And then this is equal to 0.35. Okay, so this is our percent as a decimal. And from here, we could just multiply 120 times 0.35. But I'm only going to multiply by the 5 and the 3 here. The 0 before the decimal, I'm not going to worry about. And over here, once again, I notice that there are 2 digits after the decimal. Okay, so there's 2 digits after the decimal. So we're going to have to pay that back at the end. So 5 times 0 is 0. 5 times 2 is 10, so 0, carry the 1. 5 times 1 is 5, plus 1 is 6. Put a placeholder. And then we have 3 times 0 is 0. 3 times 2 is 6. I'll get rid of this 1 that we carried before. And then we have 3 times 1 is 3. And now we just add everything up. 0 plus 0 is going to give us 0 twice. And then 6 plus 6 is 12. Carry the 1. And we get a 4 here. We have to pay back 2 decimal places. So this is going to give us 42. Okay, so how many puppies are in the class? We have 42 puppies. Okay, this is going to be our solution to question 5. Question 6, a gaming tournament has 240 competitors. 45% of the competitors advance to the next round. How many competitors advance? So for this one, let's start off by taking the percent here. 45%, we could express this as 45 out of 100, which in decimal form is 0.45, okay, 45 hundredths. So here we have the total number of competitors is 240. So we're going to take 240 and multiply by 0.45. Okay, so for this, let's just go through. 5 times 0 is 0. 5 times 4 is 20, so 0 carry the 2. 5 times 2 is 10, plus 2 is 12. Put a placeholder here. 4 times 0 is 0. We get rid of this extra thing just ahead of time. So we're at, let's see, we're over here. 4 times 0 is 0. 4 times 4 is 16, so 6. Carry the 1. 4 times 2 is 8, plus 1 is 9. And now add this up. We just get 0 plus 0 twice. And then 2 plus 6 is 8. 1 plus 9 is 10. And notice there are 2 digits to the right of this decimal. So I imagine the decimal point here, and I go 1, 2 to the left to get 108. All right, so choice C is our answer. Question 7, a wildlife center has 400 animals. 30% of the animals are birds, and 25% of the birds are injured and need care. How many birds need care? So for this one, let's start out with the total. We have 400 animals, and 30% of the animals are birds. So for this, we're going to start by taking 30% of 400. So first, let's say 30% is the same thing as 30 out of 100. And for this one, maybe I just leave this in fraction form to start. Okay, so for this, let's see how many birds there are. So 400 animals times 30%. I'll multiply by 30% as a fraction. And the reason I want to do this is I want to cross off the common zeros. You have 2 zeros here. I could cross off 2 zeros here. And now all I have to do is just multiply. I have 4 times 30. Okay, so this is 4 times 30, which is 120. So there are 120 birds. So I'm just going to point that out. So there's 120 birds, but the question is asking how many birds need care. 25% of the birds are injured and need care. So now for the next stage here, if we look at the next percent, 25%, well, 25% is equal to 25 out of 100. And this fraction, if we divide the numerator and denominator by 25, simplifies to 1/4. So if I want to take 25% of 120, I could just multiply by 1/4 or just divide by 4. Okay, so let's go ahead and do that. So we're going to take 120. So we'll just change colors here. We have 120 times 1/4. And if I do 120 divided by 4, that's just going to give us 30. Okay, so how many birds need care? We're just going to say this over here. 30 birds. Okay, so 30 birds need care. Okay, so this one here had a few steps to it, but this is our solution. In section 5, we're going to find the original amount. And the notes here we have when you are given a part of a number and the percent, you could find the original amount by doing the part divided by the percent as a decimal. So the steps here are to convert the percent to a decimal and then divide the given part by that decimal. For the first question, we have the number 6 is 15% of what number? And we could start by converting the percent to a decimal. So we'll take 15% and we could write this as 15 out of 100, which is the same thing as 15 hundredths, which is 0.15. And now we divide the given part by that decimal. Okay, so the part that we have is the number 6. Okay, so this represents over here in blue, that's the part. And we're going to divide this by the decimal. Okay, so we're going to take 6 and we're going to divide it. So we're going to divide by 0.15. Now for this one, we could do the division on the side. So we have 6 and we're dividing by 0.15. So I'll just make a little space here. So we're doing this division on the side. But what we're doing right now is we're dividing a whole number by a decimal. So I'm going to write this as 6.00. And the reason I want to do this is there's a nice little trick when you divide by a decimal. You move the decimal space to the right an amount of times that it will make that number you're dividing by a whole number. So you see, to make the whole number here, we're going to move the decimal 2 spaces to the right. So that would give us 15 if we went 2 spaces to the right. But if I move this decimal 2 spaces to the right, I have to do the same thing over here. So I could also just do 600 divided by 15, and that's going to give us the same answer as what we have over here in this fraction. So let's just work this out. We could do 60 divided by 15 is 4. 4 times 15 is 60. We subtract. We get 0. We bring down the next 0. And 0 divided by 15 is 0. 0 times 15 is 0. We subtract. And we get an even division here. Okay, so no remainder. So this tells us, if we work this out, that 6 divided by 0.15 is going to work out to 40. So we could just write this out, and our answer is going to match up with choice C. Question 2, we have the number 45 is 75% of what number? And for this one, we could follow the steps. We could take 75% and turn this into a fraction. So we have 75 out of 100. Now, the notes say to turn the percent into a decimal, but you can also use a fraction to get your answer. So this fraction I'm going to take here and reduce. So I'm going to divide numerator and denominator by 25, and we get 3/4. Okay, so what I'm going to do with this, if we follow the notes, it says to take the part. So this here, the 45 is the part, and we are dividing it by, so we're dividing by the percent, but I'm going to divide by the percent as a fraction. And when you divide by a fraction, the move is to use keep, change, flip. So I'm going to keep 45. I'm going to change this operation to multiplication and flip the fraction here. And now all I have to do is I like to cross cancel. So in my head, the math that I'm going to do is I do 45 divided by 3 is equal to 15. So I cross these out and I write a 15. And then I do 15 times 4 is equal to 60. Okay, so this is going to match up with choice B. Now, one more thing before we move on, I want to show another way to approach questions like this. So the second way is going to involve algebra. So what you could do is just write an equation that models this question. So when I see 45, so this part here, I just say, okay, 45. The word is in math, so this word is means equals. So I say equals 75%. So 75%, we'll just color code this here, is the same thing as 75 out of 100. And then of, this word of means multiply. So we would multiply by what number? That's the mystery number, is, let's say, x. Okay, and now we're just solving for x. So I could, just like before, take 75 over 100 and reduce to 3/4. So I could say, we'll say 45 is equal to, this number 75 over 100 is 3/4 of x. And now to solve for x, I have 3/4 times x. The opposite of multiplying by 3/4 is dividing by 3/4. So I divide both sides by 3/4. And notice what I get here. I'm going to have x on its own equals 45 divided by 3/4. I already did that work over here, is equal to 60. We get the exact same answer. Question 3, a bag of dog treats has 18 treats, which is 30% of the full bag. How many treats were in the bag originally? So for this one, what you could do is you could rephrase this question in a way that is much simpler, much more direct. So it's cool that we're talking about dog treats here, but when I read this question here, the way I'm hearing it is I hear that 18 is 30% of what number? So see how this turns into the same exact structure as questions 1 and 2. Because they're talking about dog treats, there's 18 of them, and they're saying this is 30% of the full bag. How many treats were in the bag originally? So this is really what's going on here. And for this one, we could just follow the same steps as earlier. We take 30% and we could express this as 30 out of 100. And for this, I can turn this into a decimal. So I can say that this is equal to 0.30. And just know for this, when you have 0.30, you could also just say 0.3. Okay, that extra 0 at the end is not needed. And when we actually divide, it's actually going to be easier to just deal with 0.3. And now what we do is we take the part. So here, see the 18 represents the part, and we're looking for the original amount. So we take 18 and we divide it by, so we're going to divide this by 0.3. Now, If this math is tricky to do in your head, the decimal is a little annoying to work with, you could use that long division strategy from before. Or what I could do is I could multiply the numerator and denominator by 10, and 18 times 10 gives me 180. And when I multiply a number by 10, the decimal of the other number moves one space to the right. So you could imagine as this decimal goes one space to the right, it's going to make 3. And then 180 divided by 3 gives us 60, which matches choice C. Question 4, an adult tracks how their weekly spending is used. The table shows the percentage of money spent in each category. So we have this table here, and we have expenses on the left. That's groceries, entertainment, household items, transportation, and savings. And on the right, we have the amounts here in percent form. And now for the actual question, if the adult spends $45 on household items, what is the total weekly budget? So for a question like this, there's a lot going on, but we have to think about what we know and what we're trying to find. So we know that the adult spends $45 on household items. So over here in the table, household items accounts for 15% of the total weekly budget. And our goal is to find what is the total weekly budget. So we have to think about what we know once again and how it connects to what we're looking for. So let's think about another way of saying this. So $45. So $45 is 15% of the total weekly budget. Okay, so this is true. $45 is 15% of the total weekly budget. And I know this because we were told that the household items makes up 15% of the budget and the adult spends $45 on household items. Okay, so that's how we can make this statement here. But you see how this connects to what we've been doing all along in this section. When we want to find the original amount, we do the part divided by the percent. So I'm going to take 15% and express this now as a fraction. This is 15 out of 100. And as a decimal, that's 0.15. And now we're going to take the 45 here. So 45, we're going to divide that by 0.15. Okay, so let's go ahead and do that. So we're doing 45, and we are dividing this by 0.15. However, when we divide by a decimal, that could be a little bit tricky. So what I'm going to do is I'm going to put a decimal and 2 zeros. And remember, I could move my decimal 2 spaces to the right on the outside if I move the decimal 2 spaces to the right on the inside. So this is just a nice little division trick here that we could use. And now instead we could do 15 going into 4,500, and it will give us the same answer as what we would get up here. Okay, so let's go ahead and do this. We have 45 divided by 15 is 3. 3 times 15 is 45. We subtract. We get a 0. We bring down the next 0. 0 divided by 15 is 0. 0 times 15 is 0. We subtract. Bring down the next 0. And I'll just move this sentence down here so we could close this out. So we'll just move this out of the way. But in the next line here, so let's just go ahead and switch back here. In the next line, let's just see where we were. So we did 0 divided by 15 is 0. And when we multiplied, we're subtracting 0. We brought down the last 0. So one more time, we do 0 divided by 15 is 0. And 0 times 15 is 0. Subtract. And we have no remainder. Okay, so we get 300, a nice whole number here with no remainders. And this is going to match up with choice C. Before we move on, I just want to point out one more thing. So we did 45 divided by 15%. But let's say I were to write 15% as 15 over 100. So for this, if I use keep, change, flip for dividing by fractions, I get 45. Changing the operation here to multiplication, I get times. And then I flip this fraction to get 100 over 15. So for this one, you see how I do 45 times 100 is equal to 4,500, and then I'm dividing by 15. But if you do the question this way, this one's really nice because you could do 45 divided by 15 is 3, and then 3 times 100 is 300. So for these questions here, you could be flexible. You could do this by dividing by the percent as a fraction or a decimal, but sometimes I find it easier to divide by the fraction. But either way, we're getting choice C. Question 5, 20% of 60 is the same as what percent of 30? So for this question, we could take things piece by piece. So this phrase jumps out at me first, 20% of 60. So for this, we could start by writing 20%, and 20% is 20 out of 100. And we could reduce this fraction. Let's divide the numerator and denominator by 20, and we get 1/5. So here, 20% of 60 is the same thing as 1/5. So I could say 1/5 of 60. So I'll start by doing 1/5 times 60. And if I do 60 times 1/5, that's the same as doing 60 divided by 5, which is 12. So now I could rethink this question. I could think of this question as 12 is the same as, so 12 is the same as what percent of 30? So in math, sometimes it's very helpful to rethink a question, okay? Think of a new way to phrase it so that the task becomes clearer. Okay, so 12 is the same as what percent of 30? That's the new question since we just found 20% of 60. Now, once we get to this stage of the question, we can just go through all of the answer choices, but let's get there in a more direct way. So we could start here by turning this into an equation. So we have 12. So this part here, I'm just going to write 12. So 12, the word is means equals. And then we have the same as, or the word, or this, how about this whole phrase here? 12 is the same as, that whole phrase means equals. And now we have next, what percent? So what percent? We'll just call that X. That's the mystery. Of in math tells you to multiply. So X times, and then the constant at the end here, 30 is just our number. Okay, so we're solving for X. So for this one, if we have 12 equals X times 30, the opposite of multiplying by 30 would be to divide by 30. Okay, so we divide by 30, we get here, and this tells us that X is equal to 12 over 30. And then we look and we're like, oh no, my answer is not there. And that's because X right now is expressed as a fraction. So we have to think back to earlier in this set of questions, okay, in the earlier sections. How do we go from fraction form to percent form? So there's a few different ways we could do this, but me personally, I would prefer to reduce this fraction first. So I'm going to divide numerator and denominator by 6, and that's going to give us 2 over 5. Okay, so X, I'll write it over here, is equal to 2/5. But one of the nice ways of turning a fraction into a percent is to make a denominator of 100. So now at this stage, I would prefer to multiply by 20 over 20, because then we will have 5 times 20 is 100 on bottom, and whatever number we get on top will tell us what our percent is. So we do 2 times 20 on top is 40. So this tells us that our mystery value here, or our mystery percent, 40 out of 100 is 40%. Okay, and this matches up with choice C. Question 6, Hank weighs 72 pounds, which is 15% of his bear's weight. What is the bear's weight? And we have to show our work. So for this one, we could use the formula from before. So we could start by finding 15% as a decimal. So 15%, that's the same thing as 15 out of 100. And then 15 out of 100 is the same thing as 0.15. So we know that Hank's weight is a part of his bear's entire weight. Okay, so the bear's weight is the original amount, and Hank's weight is a part of that. Okay, he weighs less. So what we could do now is just take Hank's weight here. So we take the 72 and we divide it by 0.15. But when we do this, so when we divide 72 by 0.15, we could use the dividing decimals trick. So I could just think of this now as we have 72 divided by 0.15 like this. I'll just put a decimal with 2 zeros, and I can move the decimal outside 2 to the right. So I'll move the 1 on the inside 2 to the right. Remember, however many spaces you move the decimal outside the division sign here, you have to move the decimal on the inside the exact same amount. Otherwise, it throws the whole question off. Okay, a little concept as to why that works. When I do 72 divided by 0.15, what I'm really doing is just multiplying by 100 over 100. And if I do 72 times 100, that makes 7,200. And then 0.15 times 100 would make 15. Okay, so that's where this idea is coming from, that I just have to do 7,200 divided by 15. So I'll just make space here and I'll write that out. So we have the space to do the division. Okay, so now I say 72 divided by 15, I could get as close as times 4. 4 times 15 is 60. We subtract and get a remainder of 12. Bring down the 0, and now I look at this and say, okay, 120 divided by 15. So little mental math here. What I'm thinking of is we just said that 60 divided by 15 was 4. But then if I double 60, I go times 2, that's going to double this and make 8. Okay, so that's how I know my next number here is going to be an 8. And if I had to check, I could do this long multiplication here on the side. So I'll just do this over here in a different color. 15 times 8, just to check. I have 8 times 5 is 40, so I have a 0, carry the 4. 8 times 1 is 8, plus 4 is 12, and that gives me exactly 120. Okay, so here, 8 times 15 is 120. We subtract, we get a remainder of 0. We bring down the next number, 0. 0 divided by 15 is 0. When we multiply by 15, 0 times 15 is 0. Subtract, we get no remainder. Okay, so we get 480 exactly. So what is the bear's weight? The bear weighs 480 pounds. Okay, so this is the bear's weight. Section 6, we're doing percent increase and decrease. And percent change compares how much a value changes relative to the original amount. And the formula we're going to use is that percent change equals the change over the original amount times 100%. Question 1, a recycling bin contained 50 pounds of paper in April and 65 pounds in May. By what percent did the amount of paper increase from April to May? So for this question here, let's use the formulas above. And first we'll calculate the change. So in the question, the 50 pounds of paper in April represents the original amount. So we have the original amount, and then we have the new amount is here, the 65 pounds in May. So this is the new amount. And this stands out as the new amount because May is later in the year than April. And now what we're going to find first is the change. The change, we'll just make this neater. The change is equal to the new amount minus the original amount. So we're going to do the new amount, 65, minus the original amount, 50, which gives us 15. Okay, so we have 15 is our change. And now our percent change, we could just go ahead and find. So percent change is equal to, we take the change, which we just found to be 15, and we divide that by the original amount, which is 50, and then multiply by 100%. Okay, so we're going to work this out. But on the side, what I want to do is I want to take 15 over 50, and I want to make a denominator of 100. So I'm going to do that by multiplying by 2 over 2, which gives us 30 over 100. And the reason I want to do this is it's going to make simplifying much nicer. So I could rename 15 over 50 as 30 over 100, and we're multiplying this by 100%. So notice the 100 over 100 cancels, and this gives us 30%. Okay, so this is a 30% increase, and we're going to get choice C. Question 2, a jacket originally cost $75. After a sale, the jacket cost $54. What was the percent decrease in the price of the jacket? So for this one, we could start by using the formulas from before. So let's first find the change. So for the change, we need to know what the original amount is. And the original amount is $75 because that's how much the jacket originally cost. And then the new price, which is after the sale, is $54. So if we want to find the change, what we could do is we could take the new amount, so the $54, and subtract the original amount, $75. But when I do this, the concept that I'm using for a question like this is I think of if I were to do 7 minus 5, I get 2. But if I reverse this and do 5 minus 7, I get negative 2. So when I want to do something like this that I know is going to come out negative because I'm subtracting a larger number from a smaller number, I could just go ahead and do 75 minus 54 on the side, but then I just make the change negative when we get to it. So 5 minus 4 is 1, 7 minus 5 is 2. So the change is equal to, we have negative $21, okay? Which means that the price of the jacket decreased. And that makes sense because we're looking for the percent decrease in the price of the jacket. Okay, so the change here is negative because the price went down. But for this question, notice all of the answers are positive, and that's because what we could do is we could say a negative percent, or we could say that is the percent we're decreasing by. So now we could just go ahead and calculate the percent change without the negative. Okay, so now let's go ahead and do that. We're going to take the change here, and I'll leave the negative out. I'm going to say 21 over the original amount, 75. Okay, and then this we multiply by 100%. Okay, so that's what we're doing. We're doing the change over the original times 100%. And I could put the negative here, but that's just going to mean that the price is decreasing. But if I just say, hey, my price is decreasing by whatever this percent is, that's also okay. So for this one, I would go on a little side quest. Okay, so let's go ahead and do that. We're going to go on a side quest here. And I'm going to work with the 21 over 75. So this, what I want to do is first reduce it. So I'm going to divide numerator and denominator by 3, and I get 7 over 25. But this is one of those nice fractions that I could turn into a fraction with denominator 100. And I could do that by multiplying by 4 over 4. If I do 7 times 4, I get 28. And if I do 25 times 4, I get 100. So this now I could say is equal to 21 over 75. I could express as 28 over 100. And we're multiplying this by 100%. And now the 100s cancel, giving us 28%. Okay, so this means that the percent decrease of the jacket was 28%, which matches up with choice C. Question 3, tickets to a school event cost $10 each. On Friday, 100 tickets were sold. On Saturday, 25% more tickets were sold than on Friday. What was the total amount of money earned from ticket sales on both days? So for questions like this, it's very important to stay organized. So first what I'll do is I'll just write Friday over here, and we'll use this space to calculate how much money was made on Friday. So we were told that 180 tickets were sold. Okay, so this represents the number of tickets. Okay, so this is the number of tickets that were sold. And we were told in the very beginning that the cost of a ticket is $10. Okay, the tickets to the school event cost $10 each. So then what we do is we could take the number of tickets sold and multiply that by $10. So I'm just going to multiply this by $10. And when you multiply a number by 10, you just add an extra 0 at the end of the number. So I have 180. I just put an extra 0 to get 1,800. And I'll put my $sign here. This is how much money was made on Friday. But we also have to calculate how much money was made on Saturday. And Saturday is going to be a little bit trickier to deal with. So first we have to find how many tickets were sold on Saturday. And we were told that 25% more tickets were sold than on Friday. So what we should do is we should find 25% of 180. Okay, so we're going to find 25% of 180. But 25% is one of those nice anchor percents. If we remember from before that when we take 25% of a number, we just divide that number by 4. And if we ever forget that, you could always just say 25% is 25 out of 100. And then you just reduce this fraction by dividing numerator and denominator by 25 to get 1/4. So really what we're doing is we're taking 1/4 and multiplying that by 180. But when you take 1/4 of 180, you're really just doing division. You're doing 180 divided by 4. So let's go ahead and do this. I could do 18 divided by 4 and get as close as 4 times 4, which is 16. We subtract, get 2, bring down the 0. 20 divided by 4 is 5. 5 times 4 is 20. Subtract, no remainder here. So this works out to 45. Okay, so we have to think about this number though. The 45 tells us how many more tickets were sold than on Friday. So if we want to calculate the number of tickets sold, so here we'll just put this back in blue, that the number of tickets sold, so this is for Saturday, the number of tickets sold is equal to the number of tickets sold on Friday, which was 180, plus the 25% increase, which is 45. So we add these two numbers together and we get 225. Okay, we could just, if we have to, we could just do something like that on the side. 180 plus 45, we have 0 plus 5 is 5. 8 plus 4 is 2, carry the 1. 1 plus 1 is 2, so we get 225. But now we could calculate how much money was made on Saturday. So we take the number of tickets sold, so that's the 225, and we multiply that by $10. Okay, so we're going to multiply by $10. But remember, when we multiply by 10, we're just putting a 0 at the end of the number we're multiplying 10 by. So we're going to do 225 with a 0, which gives us 2,250. But now we could finally find the total amount of money. So now we just add the two amounts together. So we have 2,250, and we're going to add 1,800. So we do 0 plus 0 is 0. 5 plus 0 is 5. 2 plus 8 is 10. So we get a 0, carry the 1. 1 plus 2 plus 1 is 4. So our answer is going to be $4,050, choice B. Question 4, a phone originally had 128 gigabytes of storage available. After installing apps and videos, 96 gigabytes of storage remains. What was the percent decrease in available storage? So for this question, what we could do is we could go ahead and find the change. So we have the original amount over here. So this is our original. And then this amount over here is our new quantity here. Okay, so we have the original and the new amount. So first we could find the change, which is equal to the new amount. I'll just write 96 minus the original was 128. Now I know this is going to come out negative because 128 is greater than 96. So on the side, what I'm going to do is I'm just going to subtract these two numbers here and then just put a negative in front of this difference here. So 8 minus 6 is 2, and then I could just do 12 minus 9 is 3. So this works out to negative 32. But now to find the percent change, so first I'll find the percent change. So I'll say percent change. This is equal to the change, which is negative 32, over the original amount is 128, and then we multiply this by 100%. So now from here, what I want to do with this fraction is on the side, I want to start reducing this. So I take 32 over 128, and this number here on top and bottom, I could tell that they're both divisible by 16. But let's say 16 doesn't jump out, and we just start by, let's say, dividing by 4. So this is very realistic. If you don't know what to reduce by, just pick something simple that you know works. 32 divided by 4 is 8. And I just want to point out, I know this number is divisible by 4 because if the last two digits of your number are divisible by 4, then the whole number is. So here, I'll just go ahead and do the division on the side. But if I'm doing mental math here, a nice little trick is I start by just doing 12 divided by 4, which is equal to 3. So I know I get a 3 here. And then I do 8 divided by 4 is equal to 2. So I know I'll get 32 over here like this. So that's just a nice little trick. Or once again, I could just do long division, but I just do 12 divided by 4 is 3, and then the next piece, 8 divided by 4 is 2. And this works nicely because this divides evenly. So next, I could take 8 over 32, and these numbers I know are both divisible by 8, and I get 1/4. Okay, so this fraction actually reduces to 1/4. So here, we could say that the percent change is equal to negative 1/4 times 100%. And if I do 1/4 times 100, I get 25. But notice I'm doing a negative times a positive, so I get a minus 25%. Okay, and this is our percent change. But we have to think about what the question is actually asking. They're saying by what percent decrease, or sorry, what was the percent decrease in available storage? Okay, so we're looking for, in this question, what was the percent decrease? So pay, very close attention to this. The percent change is negative 25% because the amount of storage went down. But if I want to say just the word decrease after, I could say that there was a 25% decrease. Okay, so this phrase here, 25% decrease. This, I'll just highlight here, 25% decrease saying this is equivalent to saying percent change is negative 25%. Okay, so these are both equivalent statements, but the actual question is asking for what was the percent decrease. So the word decrease is the same meaning here as this negative sign here, but this is just, I guess, a nicer way to phrase this here. If you're talking about, let's say, retail items or items that are for sale, they usually say something like % off. They don't say, oh, negative 25%, because that is more confusing to deal with. So our solution here is a 25% decrease. Question 5, a gym had 320 members in January. By March, membership increased to 368 members. For part A, how many members did the gym gain? And part B, what was the percent increase in membership? So part A is asking us to find the change. Okay, so we're going to find here the change. And I'll just go ahead and label this over here for part A. So for part A, we're finding the change, which is the new amount minus the original amount. And here, this is going to represent the original amount because this is the number of gym members in January. And then we have by March, membership increased to 368 members. Okay, so this is our new amount because March is later. And they're actually saying here that the membership increased to this new amount. So we're going to take the new amount and subtract the original amount. When situations like this, I like to do subtraction and align the numbers vertically. Okay, so I'm just going to do this and say 8 minus 0 is 8, 6 minus 2 is 4, and then 3 minus 3 is 0, so I just stop here. So the change is 48. And they're asking here, how many members did the gym gain? So I'll just actually say here 48 members. Okay, so here I'll actually write the units out because they specifically ask for how many members. So I'll say 48 members. So that is our answer to part A. So for part B, we want to know what was the percent increase in membership. So now we take the change, which is 48, we divide by the original amount, which is 320, and we multiply this by 100%. So this is another one of those scenarios where reducing this fraction can be a little bit tricky, but we could just start off with nice numbers. So let's think about 48 over 320. Let's say we divide numerator and denominator by 4 first. Okay, so I'm going to divide the numerator and denominator by 4. 48 divided by 4 is 12. And then here, I just think 32 divided by 4 is 8. So with that extra 0, we get 80. And then I look at these numbers and I say, those numbers are also divisible by 4. So I divide by 4 one more time. And then over here, that's going to work out to 12 divided by 4 is 3. And 80 divided by 4 is 20. And now this is one of those fractions that work out very nicely for percents because this is something that now we could multiply by 5 over 5. And the reason I'm doing this is when I multiply the denominator by 5, 20 times 5 is 100. And that's the best denominator we could get when we're working with fractions and we want to go from fraction to percent form. So I have a 100 in the denominator, and then 3 times 5 is 15. That's going to go in the numerator. So now we could close out part B. So we're going to take 48 over 320, and we're going to write it in this form here, the 15 over 100. And now we just multiply by 100%. When we multiply 100 over 100, these terms cancel, and this gives us 15%. But the question was asking, what was the percent increase in membership? I'll just write the answer formally over here. I'm going to say 15% increase. Okay, so I'm just going to write out the answer nicely. I'm going to use the exact language in the question. So this is what I'm writing for part B. In section 7, we're going to cover discounts, tax, and tips. And here are the notes for this section. And in this part here, I cover the definition of a discount, sales tax, and a tip. And then also at the end here, I have nice shortcuts for how to calculate discounts, taxes, and tips. Question 1, a video game has a regular price of $60. It is discounted by 25%, then 8% sales tax is added to the discounted price. What is the total cost of the game? So for this one, we just have to do things step by step. So we're starting out with the regular price here of $60, and then we have the discount is 25%, okay? So we're going to take 25% off. So what we could do is we could first find 25% of 60. So I'm going to go ahead and do this. So to find 25% of 60, what we could do is we could just take 60 and we could divide it by 4. And remember from our anchor percents that 25% is equal to 25 out of 100, which reduces to 1/4. Okay, so we could just take 1/4 of 60, which is the same thing as doing 60 divided by 4. 60 divided by 4 is equal to 15. So that's how much is going to be taken off of the regular price. So we could start by just taking $60 and subtracting $15 because that's, once again, the discount of the video game here, 25% off. So we do 60 minus 15, and I'm going to borrow here, make a 5, put a 1 over here. 10 minus 5 is 5. 5 minus 1 is 4. So $45 is the discounted price. However, we also have to be mindful of the sales tax. So if we think back to the shortcuts from before, one of the nice shortcuts here was taking the tax and adding 1 to it. And then that's what we multiply by. So when you want to charge 8% tax, you could just multiply by 1.08. Okay, so 8%, just to review, the old information is 8/100, 8 out of 100, which is 0.08. So when we do 1 plus the rate, 1 plus 0.08 gives us 1.08. So that's where this shortcut is coming from, of multiply by 1.08. So we could use that back over here, and we're just going to take the $45 now. So we take $45 and we multiply this by 1.08. But if I want to do this work on the side here, what I'm going to do is I'm going to do 108 times 45. So we're going to multiply this out here, and let's do 5 times 8 is 40. So we have a 0, we carry the 4. Then we do 5 times 0 is 0, and then plus 4 gives us 4. So that's going to go next. And then we have 5 times 1 is 5. And now I put a placeholder here, and then I'll just cross this off here. So we could start the next part here. So we're going to do 4 times 8 is 32. So I put a 2, and then I carry my 3 up here. 4 times 0 is 0, plus 3 is 3. And then we have 4 times 1 is 4. So now I just add everything up. 0 plus 0 is 0. We have 4 plus 2 is 6. 5 plus 3 is 8. And the 4 just comes down like this. But let's think about what we're trying to find here. We're trying to do 1.08 times 45. So what I'm going to do is I'm going to put this decimal back in over here. And just be mindful that we have two digits after the decimal. Okay, so you see how we have, once again, 2 digits. So 2 digits after the decimal. So when we write our final answer at the end, we're just going to take this decimal over here and move it 2 spaces to the left. So we're going to go 1, 2 like this. So we should have 48.60, but with a dollar sign, that's $48.60. Okay, and this would have to match up with choice A. Question 2, the bill for a dinner at a restaurant is $48 before tax and tip. Sales tax is 8% of the bill, and the tip is 20% of the total after tax. What is the total amount paid? So for this one, let's go ahead and first find 8% of $48. Okay, so here the sales tax of 8% is being applied to this bill here. So we're going to go ahead and find 8%. So we're going to find 8% of $48. And to do this, what we're going to do is we're going to take 8%. So we'll do this on the side. 8% is 8 out of 100. And this as a decimal is 0.08. Okay, so we're going to be multiplying $48 by 0.08. So let's go ahead and do that. So we have 48, and we're going to multiply by 0.08. And let me just make a little space. We have times 0.08. And now we could start. We have 8 times 8 is 64. So we put a 4 and carry the 6. And then we have 8 times 4 is 32. 32 plus 6 is 38. And now I could go on to the next row. So in the next row, we'll put a 0 as a placeholder. And we have 0 times 8 is 0. And then we have 0 times 4 is 0. And then from here, at this stage, we could just go ahead and add everything up. So let's go ahead, and we have 4 plus 0 is 4. 8 plus 0 is 8. And then 3 plus 0 is 3. But now let's think about this very carefully here. If we're thinking in terms of 8% of 48. So if I just break this down piece by piece. So let's say I have 48. If I found 1% versus, let's say, 10% versus 100%. Well, 100% of 48 would just be all of it, 48. But if I take 10% of 48, just imagine I have a decimal here, and the decimal goes 1 space to the right, that would be 4.8. And if I did 1%, I would divide this number by 100, and I would get 0.48. So 8% is very close to 10%. So whatever this works out to, it has to be close to 4.8. So you see, logically, 3.84 would make the most sense. So let's say I forgot that decimal trick of I have 2 decimal places that I'm ignoring, that I have to move my decimal 2 spaces to the left. This is how you could check the reasonableness of your answer. So now that we know what 8% of 48 is, so I'll just move this part over here off to the side. So we'll just get this out of the picture. That now what we just found, 8% of 48 is going to give us $3.84. So we could apply the tax now to the bill, and this is going to tell us how much our tip is going to have to be in reference to here. Okay, so we're going to add these together, and we have 0 plus 4, 0 plus 8. 8 plus 3 is 11, so we put a 1 and carry the 1, and then 1 plus 4 is 5. So after tax, the restaurant goers owe $51.84. So now next, what we're going to do is we're going to take the 51.84 and we're going to apply the 20% tip to this amount here. Now, let's say I want to use the shortcut. In the shortcut, we find the multiplier. Okay, so our multiplier here, so the multiplier, just using the shortcut idea from the notes, is we take 1 plus the tip rate here, and we're going to tip 20%. And now this I could say is 1 plus 20 out of 100, which is the same thing as 1 plus 0.20. And this I could just say is 1.2 because that extra 0 at the end is not adding any value to this number here. We always look at the last non-zero digit after the decimal, and then we don't need any extra zeros after that. So what I'm going to do with this information now is I'm going to multiply 51.84 by 1.2. Okay, so I'm going to do times 1.2. And this might look a little bit messy here, but what I'm focusing on for this is that we have 1, 2, 3 digits after the decimal that we're going to have to pay back at the end. So let's go ahead and work this out. We have 2 times 4 is 8. Then we have 2 times 8 is 16, and we carry the 1. 2 times 1 is 2, plus 1 is 3. 2 times 5 is 10. And now I put a placeholder, and I'm multiplying by 1, so I have 1 times 4, 1 times 8, 1 times 1, and 1 times 5. And now we just add all of this up. So let's see here. So this I'll just add it up without writing the plus sign here. So 8 plus 0 is 8. 6 plus 4 is 10. So 0, carry the 1. 1 plus 3 is 4. 4 plus 8 is 12. And we carry a 1. 1 plus 0 plus 1 is 2. 1 plus 5 is 6. Okay, so we look at this here. And let's go ahead and see. We have to pay back 3 decimal places. So I have my decimal at the end. I'm going to have to move it 1, 2, 3 spaces to the left. And now notice here, when we're talking about money, we round to the nearest hundredth. Okay, so we look at the hundredths place is a 0. To the right is an 8. So we're going to round up. Okay, this is going to round up to, we're going to have $62.21, which matches up with choice C. Question 3, a laptop is advertised as 25% off and costs $750 after the discount. What was the original price of the laptop? And we have to show our work. So for this one, there's a few different ways we could approach this. But what we could do is we could say, let X, so X I'm going to say is the price of the laptop. Okay, so this is the price of the laptop. And I'll say that this is the original price. Okay, so that it's clear that we're not talking about after the discount. So the original price is X. So let's think about this. If 25% is taken off, well, 25%, I'll just write over here, is once again 25 out of 100. And 25 hundredths reduces to 1/4. So what we could do is we could say 25%. So 25% of X is just equal to, or I'll just write it in the same notation over here. I'll say like this. 25% of X would be 1/4 times X. Okay, so if I'm taking 25% of X, I'm really just taking X and dividing by 4, or really just multiplying it by 1/4. So now let's think about how we combine this information here. So when 25% is taken off, it's taken off the price of the laptop. So we would take X, and then we would take 1/4 of the price of the laptop off. Okay, so you see, we take the original price, and we subtract 1/4 of that price to get the discounted price of the laptop, which is $750. And now all you have to do is just solve this equation. So when we do something like 1x minus 1/4 x, when you add x terms or subtract x terms, you just add or subtract the numbers in front. So the math that I'm doing in my head here is I'm just saying, okay, 1 minus 1/4 is just equal to 3/4. If that math is tricky to do in your head, then what you could do is you could call 1 over 1, and you find common denominators. Okay, so that first fraction I could multiply by 4 over 4, and then I would have 4 over 4 minus 1 over 4, and I would do 4 minus 1 is 3, which would give me 3/4 at the end. Okay, so here I'm going to have 1x minus 1/4 x is 3/4 x equals 750. But now when I want to solve this equation here, so I have 3/4 x equals 750. To get rid of times 3/4, I'm going to divide both sides by 3/4. So I could divide left side and right side by 3/4. So these terms cancel out. And now when you divide by a fraction, you could use the technique keep, change, flip. So I'm going to keep 750. I'm going to change the operation from division to multiplication. And then I'm going to flip the bottom fraction to 4/3. And now I just have to simplify here. Me personally, especially if I'm doing this without a calculator, when I have to multiply a whole number by a fraction, I prefer to divide before I multiply. So here, the math I'm doing in my head is I'm doing 750 divided by 3, which is a lot like doing 75 divided by 3, which is 25, but with an extra 0, so we get 250. So here I do 750 divided by 3 is 250, and then 250 times 4 is going to give us 1,000. So what was the original price of the laptop? We showed our work. The original price of the laptop, I'll just write out our answer over here, is 1,000. Question 4, two friends are talking about a cryptocurrency called Bearcoin. Alex says, I bought Bearcoin for $100, but it dropped by 50%. Now it's worth $50. If Bearcoin goes up 50%, I'll break even. Jordan disagrees, and the question is, who do you agree with? And explain who is correct and justify your reasoning with numbers. So first, let's start with what Alex is saying. So Alex started off with Bearcoin. It was worth $100, and then it dropped. So I'll just say here that it dropped 50%. Okay, so it went down 50%, and now the new price is $50. But now the next part here, he says, now that it's worth 50, if it goes up 50%, then I will break even, which means that the price of Bearcoin, Alex thinks, will go back to the original 100. So really what we have to do here is we have to take $50 and see a 50% increase of $50. Okay, so we have to see here, $50. Okay, if we increase this, so $50 increased by 50% equals, and now this is what we have to calculate. So let's go ahead and do this off to the side. Well, if we take 50%, 50% is the same thing as 50 out of 100, which simplifies to 1/2. So we could take $50 and we could multiply it by 1/2. And when you multiply something by 1/2, you're really just dividing it by 2. So 50% of $50 is $25. Okay, I'm just doing 50 divided by 2. So if we look here at what Alex said a moment ago, so I'm just going to go ahead and make space. So $50 increased by 50%, and maybe we'll make a little more space here. So we'll just kind of squeeze all of this here together. We could find this now directly. So we could just take the $50, and now we're going to add 50% of $50 is $25. So if the $50 Bearcoin goes up by 50%, it's going to go up by half of its value. So it's going to increase by 25, bringing it to a total of $75. But now let's think about this. If we look at the $75, is this the exact same amount as the original price? And it is not, okay? And this is a very common misunderstanding with stocks or any sort of investment, is that when people have their investment drop by a certain percent, they just automatically think, like, you know, if they don't think too carefully, like, oh, it just has to go up by that same percent for me to go back to where I was. But that's not true, okay? If the value of this case, in this case here, the Bearcoin goes down by 50%, going up by 50% is not going to bring us back to even. It would actually have to go up by 100%, okay? The $50 price would have to go up another $50 now to go back to 100. So the price would have to double, So Bearcoin would have to go up 100% for Alex to break even. So now we could say here that we agree with Jordan. And why is Jordan correct? Well, if we increase $50 by 50%, that brings us back to $75, which is not equal to the original $100 price of Bearcoin. One thing I just want to point out here, anytime you have a question that asks you to explain, you want to make sure you're writing a sentence with the word because here. So I'm just including here that the new value here of $75 would actually be less than the original price of $100. So that's why Alex is incorrect, and I agree with Jordan. Question 5, 2 online stores sell the same tablet. Store A is doing 15% off of a $400 tablet, and Store B is doing $60 off of a $420 tablet. And the question is, which store offers the lower final price? And we have to justify our answer. So for this question here, let's go ahead and show the work for Store A over in this section. And for this one, I'm going to use anchor percents. So I'm going to think of 15% as 10% plus 5%. Okay, so that's how I want to think about 15%. So when I do this math for Store A, what I'm thinking of is first I'm thinking of 10% of 400. And when I find 10% of 400, that's the same thing as doing 400 divided by 10, which is 40. Okay, if I had a decimal here like this, I would just move the decimal one space to the left, and that would give us 40. And then next, what I could find or think about is 5% of 400. Okay, because in a moment, to find 15% of 400, I'm going to do 10% of 400 plus 5% of 400. So for this one, I just take the 10% of 400, which was 40, and I divide it by 2, because 5% is half of 10. And 40 divided by 2 gives us 20. So now I could just write this over here. I'm going to say 15% of $400 is equal to, and I take the 10%, which was $40, and then plus the 5% was $20. So this is going to equal $60 here. Okay, so I'll just make this a little bit neater. So we have $60. And now what I do with this is I'm just going to subtract this value here from 400. So we're taking 15% off, means we're subtracting it. So we take 400 and we subtract the 15%, which was $60. And now we just do 0 minus 0 is 0. And if you know this nice shortcut, you could just do 40 minus 6 is 34. So we get $340 for the price of the tablet at Store A. If we had to here, though, of course, you can't do 0 minus 6. You could just borrow, put the 1 here, and then say 10 minus 6 is 4, and the 3 just carries down. But this value here is going to be important to getting us to the answer. So now we could look at Store B. And for Store B, we just look at what they're telling us. They're just taking $60 off of a $420 tablet. So we just take $420 and we subtract $60. And I can already tell that Store A is going to be cheaper because we're subtracting 60 in both cases, but in Store B, we're subtracting 60 from a greater amount. But let's still go ahead and show the math because we do have to justify our answer. So 0 minus 0 is 0. And then I can't do 2 minus 6, so I could borrow here. So I make that a 3 and put a 1 here. So I have 12 minus 6 is 6, and the 3 carries down. So the price of the tablet at Store B is $360. So now which store offers the lower final price? Now we just have to look. See here, this one is lower. So this one over here is lower. So we could just say here, Store A. All right, we don't have to write a long sentence here because the question is just telling us to justify our answer and which store offers the lower final price. We just have to say which store, and we showed the math for both. So Store A is definitely correct. Question 6, a clothing store advertises a 25% discount on the price of a winter coat. After the discount is applied, the price of the coat is $180. A 10% sales tax is applied to the discounted price of the coat. How much money will the customer save, including tax, compared to what the customer would have paid if the coat had been purchased at its original price with the same 10% sales tax applied? And we have to show our work. So for this one, let's go ahead and first find what is the price of the coat with sales tax at the discounted price. Okay, so let's see the discount with tax. Okay, so the discount and then with tax. we're going to find that first. Okay, so the discounted price of the coat is $180, and the sales tax being applied here is 10%. So for this one, there's a few different ways we could do this, but first what we could do is, let's just think here 10%. Okay, so we'll just think about this here, and we're going to say here that 10% is the same thing. Remember, the shortcut here is just divide by 10. Okay, so when I want to find 10% of $180, 10% of $180, really all I'm doing is I'm taking $180 and I'm dividing it by 10, which is equal to $18. Okay, so this, now what we're going to do with this is we're going to take the price of the coat, the $180, and we're going to add $18 to this. Okay, so this is the tax that's being applied. And when we work this out, we have 0 plus 8 is 8, 8 plus 1 is 9, and the 1 just carries down. So the discounted price with tax is $198. And now next what we could find is the original price. Okay, so that's going to be the next stage of this question here, is the original price of the jacket. So the original price of the jacket, we were told that the clothing store is advertising a 25% discount on the price of a winter coat. And after the discount is applied, the price of the coat is $180. So what we could do here is we could just say, all right, let X equal the original price. Okay, so this is the original price of the coat, and we're taking 25% off. So we're going to take X and we're going to subtract. So we're going to go X minus 25% of X. And 25%, this percent we've used a few times now. 25% is the same thing as 25 out of 100. And that's the same thing as, we'll just continue this idea down here. That's the same thing as 1/4. Okay, so I'm going to subtract 1/4 X. Okay, so here we have the original price X minus 1/4 of the original price X. That's the 25% discount, gives us 180. And now if I have a 1X minus a 1/4 X, that gives us 3/4 X equals 180. And now to solve for X, just divide both sides by 3/4. Okay, so we're going to divide both sides by 3/4. These terms here cancel. X equals, and now I could just use keep, change, flip. So I'm going to keep the 180. Okay, so once again, I'm using keep, change, flip. I keep 180. I change this operation here to multiplication, and I flip the fraction to 4/3. So for this question, I could do 180 times 4, then divide by 3, but it's much easier to do 180 divided by 3 is 60. And then X, I could say, is equal to 60 times 4 is 240. Okay, for this math, I'm just doing 6 times 4 is 24, and I put a 0 at the end. So the original price of the coat is $240. So now what we should find next is the original price of the coat with tax, okay? Because the question was saying how much money will the customer save, including tax, compared to what the customer would have paid if the coat had been purchased at its original price with the same 10% sales tax applied. So now the original, okay, so I'm going to say here, the original price with tax. That's what we're going to find here. So now we're going to take 10% of the original price we found was $240. And this, I'm just going to take $240 and divide it by 10. Okay, remember, that was the shortcut. The anchor percent, 10%, we just divide by 10 to find 10%. And this gives us $24. Okay, 240 divided by 10. If I had a decimal here, it just goes to the left one space like this, giving us $24. So now I would just add here the $240 plus the 10% is $24. So with tax, I'll just make a little space here. But with tax here, on the original price, someone would pay, let's see, 0 plus 4, 4 plus 2 is 6, and the 2 just carries down. The price of the coat would be $264. So now for the last stage of this question, we just have to calculate how much money will the customer save. Okay, so we want to know what are the savings here. So I'm going to just say the savings. Okay, how much money will we save? Let's say it was us buying this coat. Well, originally we would be paying $264, but now we subtract the sales price with tax is $198. Okay, so we just work this out, and I can't do 4 minus 8, so I have to borrow. I put a 5 and a 1 here, and I'm doing 14 minus 8 is 6. I can't do 5 minus 9, so I borrow, and I have 15 minus 9 is 6. The 1 minus 1 just goes away. So I would say here that the savings is $66. Question 7. A pair of sneakers cost a store owner $68. The owner wants to make a 35% profit based on the cost. However, the owner plans to advertise the sneakers with a 20% discount off the listed tag price. What price should be marked on the tag so that after the discount, the owner still earns a 35% profit, and we have to show our work? So for this one, let's break this down piece by piece. So first, we know here that the owner is buying the sneakers for $68 and they want to make a 35% profit. Okay, so these two pieces of information together are where we're going to get started. So they bought the shoes for $68 and they want to make a 35% profit, which means they want to make 35% more than 68. So first, what we could do is we could find 35% of 68. And for this one, we could use anchor percents. So there's a nice way to do this, considering I'm doing all of these questions without a calculator. And if I'm doing this without a calculator, what I'm going to do is I'm going to find 10%, and I'll just do 10% 3 times, and then I'll do 5%. Okay, so I'm going to do 10% 3 times and then 5%. So 10% of 68, and I'll write this as 68.00. I would just move the decimal 1 space to the left, and that would give us 6.80. Okay, so I'd have 6.80, and I'm just going to do this 3 times. And then for the next one, though, 5% would be half of 10%. So if I just take 6 and divide by 2, I get 3. And if I take 80 and divide by 2, I get 40. So I'm just going to add these up here. So I get a 0 at the end. And then 8 plus 8 plus 8 is 8 times 3, which is 24. 24 plus 4 is 28. So I have an 8 and I carry the 2. And I'm just going to line up the decimal over here. And now I have 6 times 3 here is 18. Plus 2 is 20. And 20 plus 3 is 23. So this means that the owner of the sneaker place here, or whatever type of store this is, needs to make $23.80. So that means that the amount that they need to actually collect here, so we're going to take the $68. So we have $68 that they need to make. Let's see, we're just going to add this up. $23.80. So at the end, let's just work this out. 0 plus 0, 0 plus 8, bring down the decimal. 8 plus 3 is 11, carry the 1. And then 1 plus 6 plus 2 is 9. That they need to see on the register $91.80. Okay, so this is what they need to make. Now we can move on to phase 2 of the question. However, the owner plans to advertise the sneakers with a 20% discount off the listed tag price. So the question is, what price should be marked on the tag so that after the discount, the owner still earns that 35% profit? So basically, we need to find a number such that when we take 20% off of that number, we get 91.80. Okay, so let's say that price is X. Okay, so what price? We'll just say that price is X. And 20% discount is minus 20% of X. So 20% is 20 out of 100. 20 out of 100 is the same thing as 0.20. So I'm going to take X and I'm going to subtract 0.20 times X. So you see this is X and I'm taking 20% off of X. And that has to work out to 91.80. Okay, so that was the first stage of this question, which is leading us now here. Well, if I have a 1 in front of this X and I subtract 0.20, then I have 0.80 times X equals 91.80. Okay, so I'm just doing 1 minus 0.20. A nice concept for these questions that I still use is that if I just imagine here, let's say I'm taking 20% off. Okay, if I take, I'll just make this idea a little bit bigger here. So I'll just draw this maybe in this little section over here. So I'll just say, so we have the space that, once again, if I take 20% off, so 20% comes off, that means how much is left for the one whole 80% is still on. Okay, so that's just like something I say in my head. When I take 20% off, 80% is still on. So that's why there's a 0.80 in front of the X. But now to do the algebra here, we're just going to divide by 0.80 on both sides. Okay, so it's 0.80 times X. So the opposite of multiplying by 0.80 would be dividing by 0.80. These terms here cancel, and now x equals, and we're just going to divide these two. So now we're going to divide this out. But one thing I want to mention first is if I'm doing 91.80 and I'm dividing that by 0.80, see how we have these extra zeros at the end? I don't need these extra zeros at the end. I could get rid of them because those zeros are after the decimal point and they're at the end of the number. So getting rid of that zero is just going to make the division step much easier. And now I could do something like this. I could do 91, so let's see, 91.8, and I could divide that by 0.8. Or what I could do is I could move the decimal one space to the right on top and bottom. And the reason why we're allowed to do that, so just to highlight the concept a bit, so I'm just going to move this over here. So this here, I'll just show, if I were to go times 10 on top and times 10 on bottom, that gives us 918 divided by 8. Okay, the decimal just moves one space to the right on top and bottom. So that's the division I'm going to do here. I'm going to do 918 divided by 8. And now I can say 8 goes into 9 one time. 1 times 8 is 8. Subtract. Remainder 1. We bring down this. 8 goes into 11 one time. 1 times 8 is 8. Subtract. Remainder 3. And now I bring down the last 8. So we could do 38 divided by 8. And for this one, we could get as close as 4 times 8 is 32. We subtract, we have a remainder of 6. But if I have a remainder of 6 over my original divisor is 8, let's break down that fraction as well. 6/8 is the same thing as 3/4. And just think 3/4 is the same thing as 75 cents. So that's 0.75. Okay, if I had to, I could turn 3/4. Like if that idea didn't make sense, that quick math, I could do times 25 over 25, and that gives us 75 over 100, which is 75 hundredths. But this is just the idea to help us build up to the answer. So here, x I could say is 114.75, and this is the price that the owner should charge so that they make their 35% profit, even after giving a 20% discount. So let's write the answer out formally here. So that'll be 100, let's just make sure we write this neat. So we have $114.75.